Now, power of the Fisher projection. It is fantastic for working with chirality. So, previous video we worked on this 5-bromo-2-hexanol, and when we have this wedge dash notation, go see the previous video, we end up with 2R5S for the chiral centers. So, what does it look like when you look at an enantiomer with a Fisher projection? Well, an enantiomer is when you actually take the mirror image of the molecule and you get basically what that mirror image would be. So right now, as drawn, we have the hydroxide on the left and the bromine on the right. And so this is your R center, and this is your S center. Well, if we take a mirror image, the way we do that in a Fisher projection is we just swap what's on the left and the right sides. So in this case, hydrogens don't matter, but we end up with H, Br, and H, OH. Now, in terms of this drawing, we're going to flip the wedges and the dashes. And in terms of the assignment of the chiral centers, an R is going to become an S, and an S is going to become an R. So if we know our parent compound and we want to figure out what the enantiomer is, we just flip the assignments for the R and the S's. And we flip their positions on the chain. So our OH and our Br here are going to flip. We're going to go from 2R, 5S, 5-bromo, 2-hexanol, to 5S, 2S, 5R, 5-bromo, 2-hexanol. What happens if we only change one of the chiral centers? So let's say, instead of taking the direct mirror image, I just flip the hydroxide and leave the bromine where they are. In a Fisher projection, switching sides left to right is going to switch from R to S. So this will become 2S, 5S, 5-bromo, 2-hexanol. But here's the problem. Changing one chiral center when you have more than one, you don't get an enantiomer. So enantiomers only happen if you change all the centers at once. If you only change one, what you end up with is this diastereomer. So a diastereomer is basically what happens if you take a multi-chiral center molecule and only change one. They are not mirror images of each other, but they do have different chiralities. They do have different R and S notations for their different chiral centers. Now,